Hi everyone! In this video, I will show you how to extract text from PDF files. I won't cover the other document types because extracting text from them is straightforward. Extracting text from PDFs can be challenging because they might be scanned, have complex layouts, or contain text in different orientations. We also need to deal with images, tables, and other elements that can be present in these types of documents. In Python, there are many libraries that can extract text from PDFs, such as PyMuPDF, PyPDF, and PDF Plumber. Let's take this page that I took from a PDF file. If we give it to one of these libraries, the output will contain the selectable text on the page. Let me zoom in on this small text in order to verify the result. Notice that Quantum Black AI by McKinsey does not appear in the output. That's because this text is not selectable. The rest was extracted by PyMuPDF, but the order is wrong. For example, if we look at March 2025, here it appears in the end of this page, but in the output it appears after the title, which is wrong. And also, let's look at the subtitle. Here it appears directly after the title, but here in the output it appears at the end of the text, which is not correct. These Python libraries are ineffective because they don't preserve the document's structure. We will see some complex examples in the next slides that show the limitations of these tools. So, if we shouldn't use these libraries to parse PDF documents, what should we use instead? The answer is Vision Language Models. VL models can see images, read and understand text, and combine both abilities to parse an image effectively. This time the output is perfect. The structure is preserved, and the model even extracted the non-selectable text. Also, notice how it added the new line character to match the style of the original page. So instead of having Quantum Black AI by McKinsey in one sentence, the model understood that there is a new line character that should be added. And the rest is also good. So you see here we have the title next to the subtitle, we have a new line, and here we have the authors, and finally we have the date, which is March 2025. You might be asking, what is the trade-off? Let's compare both methods side by side. Python libraries are free and open source. VL models can also be free, but we also have paid options. Libraries can't handle scanned documents, while models can. When it comes to resources, you don't need a powerful laptop to use the libraries, but that's not the case with VL models. Here you can see that I have two values, high and low. If you decide to run the models locally on your laptop, you need decent hardware. You need to have a GPU in order to get fast responses. Here, low means that instead of running the models locally, you will connect to an API and use the model that is hosted on the cloud. VL models have a clear advantage because they preserve the structure of the document, they handle complex layouts, and understand the content of each page. However, models are slower than traditional libraries. Overall, VL models perform better, but it depends on your use case. If you are working with simple documents, use Python libraries. If you have thousands of documents with different layouts or need to extract specific information, go with VL models. As I said, we will compare both these methods in complex examples. This is an image that I took from the same documents that I mentioned in the beginning. And you can see that here we have a lot of stuff. And in the middle, we have this chart, which contains 6 vertical stacked bar charts. And we have a lot of tags. So let's test both methods to see which one will perform best. Here is the output from PyMuPDF. Look at the numbers inside the chart. You can see that here we have 50, 57, 46, 36, and we see them here in the output. The problem is that each number is placed on a separate line. The words McKinsey and company don't appear in this image, which means that this text is extracted from another section. This text that I highlighted shouldn't appear at the beginning of the output, because as you can see, it appears below the chart, which means that PyMuPDF should have extracted this after the main content. And finally, you can see that it swapped the title, and the title now is appearing after this. The title should be at the top. Here is the continuation because I couldn't show the full output in one page. You can see that here we have another problem. Here, if you look at the image on the right, we have the legend. So each color means something. For example, the light blue color means fully distributed. This gray color means hybrid. And this dark blue color means fully centralized. We can see that output here. You can see we have fully centralized, hybrid, and the other one should be below. But the problem is that instead of getting just one sentence, PyMuPDF decided to split the output across multiple lines. This is not a problem because this is how it appears visually. But it will be better if we could get them in a single sentence so we don't have to remove all those new line characters. That will save us a lot of time. Now let's look at the output from the vision language model. Here I decided to use Gemini 2.5 Pro. The result looks much more organized. The title appears at the beginning, like we see in the image. The model also gave a description of the image because I asked for it in the input prompt. This is something really great about these models, is that you can describe what you want. Pause the video and read the description if you would like. I have highlighted some terms that appear in the charts to show that the model actually understands what it is seeing. For example, here we have centralized hub model, we see it here. We have decentralized spoke model. We have fully centralized, hybrid, and fully distributed. That comes from the legend, etc. And instead of listing the numbers inside the vertical bars, line by line, the model produced meaningful explanation. You can see that let's take risk and compliance as an example. Here it gave us 57% fully centralized, 30% hybrid, and 13% fully distributed. Let's look at a second example. As you can see, it is complex. It contains a lot of graphs. And again, I took it from the same report. Let's start with PyMuPDF. Unfortunately, PyMuPDF still doesn't give us a good output. It repeats the same mistakes. You can see that the numbers are, again, split by line, which is not ideal. Let's look at Gemini 2.5 Pro again. Let me say one more time, the output from the model is excellent. Try reading it, you will be impressed. The model correctly identified that there are 14 charts, as you can see. Here is the description of the image that Gemini 2.5 Pro gave us. It says that the image is composed of a series of 14 area charts, and it knows that we have 2 rows and 7 columns. This is why I told you in the beginning that these models can see and read and understand text, which is really awesome. It also was able to read the values in the x-axis and in the y-axis. So here it says between 0 and 50. One thing I noticed is that in this case, the model started to guess some of the values. I actually think that this is interesting because the guesses weren't bad. Let's look at the inaccuracy line plot. The model estimated that the values should be 32% and 45%. If we look at the first points, you can see that it is higher than 30 and it is close to 32%. That's good. And here the other point is higher, is between 40 and 50. That's why I said that the guesses were not bad. I am mentioning this so you are aware that models can sometimes add information that isn't there. It is always good to double check the output. In this course, we will verify everything manually because we want a high quality dataset. That's fine, since we will only need a few hundred samples, not hundreds of thousands. But even with that, the model saves us a lot of time. Without these models, we would waste countless hours cleaning the messy outputs that we get from, as you saw, from PyMuPDF or the other Python libraries. VL models will help us create high-quality datasets by annotating images. We don't want to remove this from the dataset. The models can describe tables because, again, tables are full of values, but if we just store those, they don't mean anything. We need to have context. So with these models, we can describe the content of these tables and also output them in a nice format like Markdown. We can preserve the layout. We can extract only what we need from the documents. So for example, if you want to extract, let's say, just the titles or some keywords or something from the documents, you can write a prompt that will instruct the model to look just for those values and ignore everything else. The most important thing is that these models can handle scanned documents. If you try to use PyMuPDF, the output will be an empty string. There are other OCR solutions, but they don't perform as well as the vision language models. So which model should you choose? You have two options: proprietary models or open models. You can use both through APIs. It is cheaper than hosting your own GPU server, but if you already have the hardware, you can host open-weights models locally. Just keep in mind that this is expensive. Finally, I want to share two leaderboards you can use to track the best models. We have OpenVLM and the Intelligent Document Processing leaderboard. That is it for the theory. Now let's move on to practice. The source code is available in this GitHub repository. You'll find the link in the video description. I have opened the project in VS Code, and here I want to show you the notebook that you need to open. Open the notebooks folder and choose basically the first notebook. Inside the data folder, you'll find the documents that I will be using in this course, and also some images that we will use for testing. If you click on this one, you can see that this is the image that I showed you in the slides. Now let's go back to the notebook. First, we will start by using the Python libraries. And also, before I forget, you will find the requirements inside the requirements.txt file. Here are all the dependencies that we will need. Here I am using PyMuPDF, but feel free to use the other ones if you want. Let me show you the documents that I will be using in this notebook. It's called the State of AI. So this is the document. It contains 26 pages. Let me go back to the notebook and let's start by running the first cell. You can see that PyMuPDF correctly identified that we have 26 pages. That's good. And in order to extract the text, you can loop over the document. This will allow you to loop over the pages. And from each page object, we can call the getText method. This method will go through the page, extract the selectable text that it finds there. And if I run this, you can see that I get this thing. So it says that extracted 50,000 characters of text. I am doing this just to make sure that we get something, because we'll see later if we have a scanned document, we should get an empty string, which will return 0 characters. Let us print the first 2,000 characters just to see how the output looks like. As you can see, we have a lot of new line characters. This is exactly what we saw in the slides. So again, here is the first test that I have conducted with this method. This diagram or this figure appears in the 5th page. Here, because this is 0 indexed, we select 4. If I try to get this text and you can see that we get a lot of output from it because we have other stuff other than the figure. But let me put it here on the side and let's look at it. You can see that here we have exhibit 1, that's correct. And here are the numbers that are inside the bar chart, but this is not ideal. And again, we have a lot of new line characters. When you are done, make sure to close the documents if you no longer need it. So let's do that. And now let's load a scanned PDF. So basically I took a PDF and I converted it into images. The PDF is this one. As you can see, I converted it into an image. As you can see, I cannot select anything, and I made sure to decrease the quality of the image just to test the performance of the vision language models. So let me close this document and let's try to use PyMuPDF to basically read text from it. First of all, we just check the number of pages. This is correct. We have 19 pages. After that, we use the same thing, but this time we get 0 characters because this is a scanned PDF. So this is the problem. If you have a lot of scanned documents, you can't use these Python libraries. But luckily we have multimodal models or vision language models. Multimodal means many modalities. A modality can be text, audio, video, images, and here these models can understand 2 things. Images and text. This is why we call them multimodal models. Here I will start with proprietary models. I will use Gemini, but feel free to use OpenAI's models or Grok or any other proprietary model. I use Gemini because I really love that 1 million context window, and it is currently the best model at document understanding tasks. If we look at the leaderboard that I mentioned in the slides, the intelligent documents processing leaderboard, you will see that Gemini is basically the best. So this is why I am using it in this notebook. With Gemini, you need to do some things in order to be able to access the models. First, go to Google AI Studio and make sure to create an API key. Click on this button and give the API key a name. Choose a project. If you don't have a project, you can create a new one. And after that, you can click on the key, copy it, and paste it in the .env file. Now, when I use the .env package in Python, it will load that API key. And if you are wondering what you should put in the .env file, basically you need to have this thing. So the key should be called Google API key, and here you paste the key that you created in Google AI Studio. After you do that, load the keys, and here, as I said in the slides, we can instruct these models to do a specific task. For example, here, if you read the system prompt, you will see that I told the model that we will give them a PDF document, and the goal is to extract the entire text. I mentioned that the document can be simple, complex, or even scanned, just to let the model know that the variations of the documents that he might encounter. I've also made sure to explain that the model should examine the documents page by page, because here you have 2 options. You can either pass 1 image at a time or 1 page at a time, or give them the full PDF document to the model. And the model will try to understand or will try to analyze the document page by page. And here I said that when you come across text, extract it as is. I don't want the model to add anything else. And also I have made sure to tell the model that if it sees images, to give us detailed description, because this is very important. We don't want to skip images. Also, we have something we tell it if it encounters tables to describe them also like images, etc. And finally, we say here is the PDF, and after that we will provide the PDF document. After that, here is how we use the Google Generative AI package. It's really easy. You can see that here we specify the document path. Here is the prompt. Basically, this is going to be the user prompt. This one is the system prompt. And here is how we use this. Here I am using Gemini Flash, but for you can also use Pro. I use the Gemini 2.5 Pro because it is very good, especially if you have big documents. Gemini Flash It's good if you don't have complex documents, and it is faster than Pro. But here, just for testing, I am using Gemini 2.5 Flash. And also keep in mind that with the free tier, you have access to both Flash and Pro. Here in the rate limits page, you can see that we have requests per minute, tokens per minute, and requests per day. And here are the tiers. Basically, when you create an API key, by default, it's going to be in the free tier, but you can upgrade it to tier 1, 2, or 3. And here are the models. So for Gemini 2.5 Pro, in the free tier, you get 5 requests per minute. That's really great because processing one document will take 1 or 2 minutes, especially if that document contains dozens of pages. And for Flash, we get 10 requests per minute. This is very generous, and I really like this, especially if you want to test the model before going to tier 1 or the other tiers. And if you jump to tier 1, you get 150 requests per minute. Something to keep in mind. So this is another page that I will link in the video description. It talks about API pricing. Here in Gemini 2.5 Pro or the other ones, this is similar. Here, if you use the free tier, the documents or all your conversations will be used to improve Google's products. But if you go to the paid tier, they will not use your data to train the models. So if you are using the company's data and you don't want Google to use those documents to train their products, then make sure to use the paid tier. Or if your company is using Vertex AI, that one is secured and they will not use your data. But for the free version, if you want to try it on documents that you can use, that are publicly available, just to understand if this model will be good enough or not. Same thing for Flash. You can see that here for the free tier, they will use your conversations to improve their products. Otherwise, for the paid tier, they won't use this. So this is something that you should keep in mind. Now let's go back to the notebook. And here I am using Gemini 2.5 Flash. I provide the prompt. I pass the whole PDF document. This is really great. So instead of having a for loop, looping over the pages, we just give the PDF to the model. And after that, we add the user prompts. Okay, so the user prompt says, extract the text from the PDF, please. And the model, based on the system prompts, will know what to do. Also keep in mind that there is a limitation. If you decide to upload PDF files, they should not be longer or larger than 20 megabytes in size. If this is the case, make sure to compress the documents or separate them. So if let's say that the document contains 500 pages, you can separate it into PDF files that contain just 100 documents or less. It depends on the size of the document. Or you can use the File API. The File API allows you to upload the document in Google's servers. This way you can upload bigger files and use them in your prompts. And after that, they will be automatically deleted after 48 hours, if I remember correctly. You can check that information by clicking on this link. And as you can see, they mentioned that the File API allows you to store 50 megabytes of PDF files, and they are going to be stored for 48 hours. After that, they will be deleted. I'm also controlling the output. This is important because if you have bigger documents, you need to allow the model to generate a lot of tokens. I think the max output tokens is 64,000 tokens or something like that. But here, since this document is not that big, 32,000 is very enough. Okay, so now we can run this and let's wait. After that, in the response, we can access the text attribute and get the output. Instead of waiting, let's just open the document and let's compare the result. Let me put the document right there and VS Code on the left side. Let me also click on text editor and let's look at the output. So first, you can see that here we have Rockstrix that appears here, Gaming Notebook PC, and after that, it went straight to the second page. So it did not extract this information. And after that, it says copyright information, etc., no part. And then we have the table of contents that appears here. Let me decrease the font size so that we can see everything. let's see. So the last one is 109. As you can see, it says simplified UKCA declaration of conformity. That's right there. Okay, so it seems to be working. Let me go to the last page. Here we have something about color. So you can see that, for example, here we have a table and it converted it into a markdown format. You have color, status, solid white, solid orange, blinking orange, lights off. After that, it also extracted these things and the notes. So it seems to be working. Sometimes if you get something that is missing, if you want to add these terms, you can just edit the output. So the request has finished. It took 43 seconds with Gemini 2.5 Flash. And as I said, we can get the text from the text attribute. And now I got another response. Okay, so this time the model was able to extract this. So high definition multimedia interface, that's correct. Revised edition v5, December 2024. And here it tried also to describe the image. So here it says a dark metallic background with a prominent style, etc. So it is trying to describe the Asus ROG logo. So if we don't need this, we can just delete it afterward. Okay, now let me close this document because I no longer need it. And after that, let's save this output. It's better to save the output so that we can open it like this and start editing the output as we like. We will see this in the upcoming tutorials, but for now, I just want to show you how we extract text with vision language models. So that was Gemini, and as I said, if you want to use other models, feel free to do that. But this is the go-to model that I use when I want to extract data from PDF documents. So now let's close this with proprietary models section. And let's go to open source models. We also have very good open source models that can do the same thing. And here I will start with the Granite docling 258 million parameter model that IBM has released. And I'll show you two ways of using it. We have the transformers library. And here you can see that we have this class, auto model for image text to text. And here we specify the model. And here we are using PyTorch. And it will automatically detect if you have a GPU or a CPU. If we run this, for the first time, this code will download the model from Hugging Face, but later it will just load it from the cache. So that will be faster. In my case, I have already downloaded it. That's why it's not going to take a lot of time. And here, if I try to print device, you will see that it will give me CUDA because I do have a GPU. But if you don't have it, the code will fall back to use a CPU. Having a GPU will definitely help get results quickly because you will see that here we have a problem with the transformers implementation. So first of all, we load an image because this model expects images. And here we create the messages list. Here we have two roles. We have the user role, we have the user role, but we specify two things. We specify the image and the prompt. So the prompt is convert this page to docling. This model, you can see that it is very small. It has 258 million parameters. That's not big. But the trick is that this model was trained specifically to extract text in a structured way from PDF documents. This is why it is very performant, even though the size is not that big. So here in the messages list, we provide the prompt and the image because this is what the model expects, and this will give us the list of inputs. If we print the inputs, you will see that this is, let's look at it. Okay, you can see that this is just a tensor. So we have the pixel values that comes from the image, and we also have, so I had to do some transformations in order to get that value, but we have the pixel values and the input IDs. The input IDs come directly from the prompt. After that, you just run this. So you specify the number of tokens that you want to generate. This depends on the amount of text that is present in the image. You call the generate method and you wait. After that, you get something that they call document tags. So let me run this because it is going to take 5 minutes to process. Even though this is just an image and I am using a GPU, for some reason, it takes a lot of time to process this. And this is a bug that everyone seems to have, but luckily there is a solution to this. We will see it later in the upcoming cells. And as you can see, these are the tags. Basically, as I told you, this model was trained specifically on this task, and the model, when it finds something, it tries to give you a bounding box. So for example, this text, let me show you the image that I am using. So test OCR is the image that we are testing. And if we look closely, you can see that here is the title, energy budget of something, etc. Here it is. So this is the title. And here the model is giving us the bounding box. And here it's also telling us that this is the page header. So these are tags that keeps the semantic, which is really cool. And after that, we also have, let's see, we have other stuff like formulas. Here you can see we have text, we have section header level 1, etc. So we have these tags that this docling model works with in order to extract the text from images with high accuracy. So as I told you, this is going to take 5 minutes, but instead of waiting, I'll just walk you through the notebook. Let's see the next step. You can see that here we are calling the from doc tags and image pairs. Basically, we'll provide that output that we got before and the image. This will clean the text. It will just give us the text inside those tags, and we can export it as markdown. And we use the display method to display that markdown. I'm not sure if you are hearing my GPU, but you can see that here the temperature has risen because the model is running. So I hope that you don't hear that noise, but let's keep going. I will bring the image again. Let's put it on the right side and let's look at the output. So you can see that because the output is in markdown, we can render the formulas. As you can see that the model is doing a great job, and this is a complex document. The layout is not. Try to give this PDF document to PyMuPDF. You will not get something like this. It's going to be extremely difficult to clean the output from the Python libraries. This is why it is really cool to have these vision language models that understand the complexity of the layout and give you the text in a clean format. Even though they will never be 100% correct, but at least if you want to modify the output, it's going to be easier for you to do that. Let me go back to the previous cell just to see where it is. As I told you, this code will take 5 minutes before giving us the output. Let's print this, and as you can see, I get the same output. Let's keep going, and let's run this just to make sure that it's working. And yes, it is. Again, save the output to a text file so that you can modify it later. I told you that even though this is a problem, luckily there is a solution. We can use a project called llama.cpp. If you are not familiar with llama.cpp, it is a project that was created in order to make it easier for everyone to run models locally. And it is efficient and it allows you to run models on CPU and GPU very efficiently. And the project, you can find it on GitHub. Here it is. The people who are working on it, they try to support all the models that are on Hugging Face. And to set up llama.cpp, you can read the README file. They have all the steps that you need to follow in order to install it locally. Or if you want, you can read my article. I have created an article where I explained how to install llama.cpp, llama.swap, etc. locally. If you are interested, make sure to read this article. I'll make sure to link it in the video description. So now let's go back. And llama.cpp works like this. Basically, you need to download a model. Click on this link. It will take you to the ggml org repository. Here they have added the Granite docling model. So how this works? Basically, you need to download the model in this format, gguf. If you look at the model that was uploaded by IBM and click on files and versions, you can see that this model comes in the safe tensors format, and llama.cpp does not understand this format. You have to convert it. Luckily, people in the community convert these models for us into this format that llama.cpp understands, which is called gguf. And the cool thing about this is that you will have just one file. But with safe tensors, especially if the models are big, they are going to be split into multiple safe tensors files. Make sure to download one of these models. And here you will see that here we have one with Q8 and this one is F16. So Q8 is a version that is quantized. You can see that the size is basically half of the F16 model. And here the F16 model will have high precision, and this one will have half of that precision. And after that, we have the embedding. Why do we have two files? Because here llama.cpp will divide the model into two parts. This embedding will contain the vision part, and the other file will contain the part that understands text. So this is why we need to download both of them. So if you select F16, download the text model here and download the embedding. This is exactly what I explained here. And after that, we need to run the llama server command. This comes with llama.cpp and it allows you to host the model. Here we are going to host it locally, but you can do the same thing if you want to host it on one of your servers. And here you specify the model and the embedding files that we have downloaded from that repository. The number of GPU layers, here it is set to 999 because this is a small model and I can fit it in on my GPU. The context size is the input that I can give to the model, and finally the port. I will copy this just to show you how this works and run this here. And as you can see, here it says server is listening on this port, which means that I can use the model. Okay, so here we have a function that will convert the image path into data URI because this is what the endpoint expects. So we give it the image path and it converts it into this format. So let's look at it just so that you can understand how it looks like. The first part is data. This is an image and the extension is PNG. And after that, we convert the image into base 64. So this is the input that we will send to llama.cpp. Here is the port that we have specified. It's exactly the port that we can see in the terminal. And after that, we have this function that will take the model name, prompt, and image data URI. The content type is JSON because we are going to send this list of messages. You can see that we have the same thing. We have the role set to user, and we have two inputs. We have the prompt and the image. After that, we specify the max tokens to generate. We give the messages, and we send a post request to the server. After that, we decode the response and we get the content. Okay, this is how we use it. So we provide the model name, the text prompt, and when we call the extract test from images, I will quickly, or let me just put this here and open GhostC on the other side of the screen. And let's run this. And as you can see, I was able to get the response in less than 6 seconds. And here it gives me that the tokens per second, the generation speed is 344 tokens per second, which is way faster than using the transformers implementation. We have this function that we can use in order to remove those tags, because if I print this, the only problem with the llama.cpp version is that we don't have those semantic or those tags that keeps the semantics. You can see that here we just get the bounding boxes, but we don't know if this is a header or a formula. So sadly, the llama.cpp implementation does not add those tags. But it's not a problem because this is just a text that we can modify later manually. We have this function that will strip those tags and will give us this. You can see this is the title, the page number, etc. And we have the LaTeX formulas. Okay, so this is how we strip the tags. And again, you can save the output if you want. And this is the code that will loop through the pages, extract the text, and append that to this variable that will contain the extracted text from all pages. I am getting this error because I think what happened is that I have reassigned this variable somewhere. Let me see. Yes, you can see that here when I ran this, I have reassigned. So this output is stored here. So I need to rename this so that we don't get that error. But let me run this code that will load the file. Yes, this one. So I need to get the document and use it in that code. Okay, so let's use this document, the Rockstrix gaming notebook, and let's run this. And as you can see, here I am using TQDM in order to get this progress bar. And yeah, it seems to be working. let's see. So let's open the text editor. Okay, so here the output seems to be good, but we have some problems that we can fix later. And here we have a lot of new lines. Something bad must have happened in this page. As you can see, this is the problem with small models, is that yes, they work most of the times, but sometimes they might break for some reason. I'm not sure, maybe because the image quality is not that great, but at least it gave us inputs that we can filter manually later. Okay, so after that we can save this if we need. The previous model that we looked at, the Granite docling model, is, as I said, is a model that was specifically trained for this task. We have other open source models like Geometry 12 billion parameter models, the model which was created by Google. There is a bigger version, 27 billion, but sadly it is very slow on my hardware. That's why I didn't use it, and I went back to using the 12 billion. And the process is similar. You just search for this model on Hugging Face. Make sure that the name contains GGF, and luckily Google has provided this model, which is great. So make sure to download both files and run the server, but this time use Geometry instead of docling. And this model is different than the docling model because this is a general model. It was not trained specifically to perform text extraction from PDF files, but this is similar to Gemini 2.5 Pro. You can give it a system prompt and describe the tasks that you want the model to perform. So here I am loading the same image just to compare the result from this model to Gemini 2.5 Pro and docling. The system prompt that I am giving to Geometry 12 billion is similar to the one that I gave to Gemini 2.5 Pro. I'm not going to run this because it took 6 minutes. This is a dense model. The size is way bigger than the docling model, and it takes 6 minutes. This is why I said in the introduction that you need decent hardware to run these open source models. But I'm not going to run this, but I can just show you the output. You can see that here again we have the title. But since we have a lot of text, I decided to compare the three models down below. So here I'm comparing Geometry, docling, and Gemini 2.5 Pro, and here are the outputs. So Gemini 2.5 Pro, it perfectly extracted the text. Here I'm just looking at the first paragraph. Geometry, the output is not bad here, but it made some mistakes in some words. And finally, the Granite docling model worked perfectly, exactly like Gemini 2.5 Pro. The output was very good. So this is really, really awesome. So you can see that this model is way smaller than Geometry, but because it is trained specifically to do this task, it matches the performance of Gemini 2.5 Pro. So yeah, that is it for this video. I hope that you learned something from it. I know it is long, but I tried to show everything in detail so that you don't miss anything. If you didn't understand anything, feel free to comment on this video. See you next time.